Okay, so let's continue talking about mating systems in birds and how they distribute themselves among their habitats during the breeding season. So we were wrapping up talking about monogamy last time, and this is the last slide we talked about. And really the reason why most birds are monogamous is most birds have altricial young that develop that are hatched at a very underdeveloped stage, and really do require both parents to take care of them. And that even includes sharing incubation duties, as was shown with this study on European starlings. So we talked about the efficiency when both the male and female are incubating, how it narrows the range of temperatures the clutch experiences compared to when the female has to do it herself. But the one thing I didn't explain in this slide was the line about females attacking potential rival females. And remember, when we talked about extra-pair copulation, that's one of the potential things that females can lose out, is if a male feels like he has more paternity associated with a nest, that he has had extra-pair copulations, he might abandon his monogamous mate. And so she would want to minimize that risk as much as possible. Okay, but monogamy is not the only mating system that we see in birds. The next type generally is called polygamy. And this is where you have one individual of one sex mating with multiple individuals of the other sex, and at least establishing some type of pair bond with at least two of those individuals. Now you can break that up into polygyny or polygyny, referring to the fact that you have one male mating with multiple females. Let me see if I can get this pen to work here. And so where you see these solid lines like this, that indicates that is the polygynous aspect of this relationship. So that male in his territory, if it's a red-winged blackbird, has two females that are nesting in his territory. This female right here that's associated with a dashed line, that's indicating an extra pair copulation. So he could also be mating with other females outside of that territory. Now the opposite, the reverse of that is polyandry, in which a single female mates with multiple males, and that typically is associated with those males staying with her in some type of breeding association, oftentimes with them establishing separate nests in her territory and she laying a separate clutch of eggs for each of those. So let's talk about polygyny first. There are different ways that you can break down polygyny. So the most common is what's called resource defense polygyny, and this is where dominant males in a species can really capitalize on getting the highest quality territories, and there's a lot of range in the quality of habitats, the quality of the habitats that are available. So you've got some really high quality ones, a few of those, and then maybe a few kind of medium, and then quite a few that are just borderline acceptable for raising young. These clump type of resources tend to be very common associated with marshy habitats, where there's kind of a narrow range of habitats associated with where the water meets the vegetation, and then it gets into drier habitats. So that marsh is very kind of scattered as far as the resources that are available. So a marsh wren, a red-winged blackbird, indigo buntings are examples of polygynous species. And the males that defend the highest quality territories, guess what? They're the ones that are attracting more females to the territory. And if we're talking about a species that typically has a 50-50 ratio of males and females, that means some males are just going to be out of luck. So if you are a female, there are various options available to you. So let's say that you're a female red-winged blackbird, and you're trying to decide to join a male on one of these two territories. The one on the left, the greener one, is associated with a high quality territory and probably a higher quality male genetically. And so obviously that's who she should choose. But it turns out that he is already mated to another female. Okay, well, she could be getting the better genes with him, better access to better resources, but remember the importance of biparental care. She may not be able to get much help raising the young with this male because he's probably going to spend more of his time associated with the nest of a previous female in which they're kind of farther along in the breeding process. So her other option is to maybe mate with a male that's on a lower quality territory, so that she may not have quite as good a quality male, maybe not quite as good a quality resources, but she could probably get more of his parental care. And that's assuming, though, that hear the northern cardinal in the background there. That's assuming that another female subsequently doesn't join that territory. So it's a tough choice for some of these females. Now, there obviously is one other potential advantage of mating with a lower quality male if he happens to be bordering a higher quality male. She can mate with him, get all of his parental care, or hopefully, and then have extra pair copulations where the more dominant neighboring male get his genes and maybe even get access to some of his resources. There's another type of polygyny called female defense polygyny. So the last one was called resource defense polygyny. The males are defending these territories that are different values. Female defense polygyny, the females are already in these clusters that they self-form. So they've started nesting in, for example, this tree, as you see these orpinulas doing. So the male that can be dominant and take over this cluster of preformed females is going to be the successful male mating with all these females. But again, females in this situation, males that are not the controller of this group of females can still receive some extra copulations. These are sometimes referred to as satellite males, kind of hanging around the periphery looking for options to mate. And we've already talked about reasons why a female may want to make sure she mates with at least a couple of males, for example, assurance of fertility associated with the male that she is mated with. Polyandry is pretty rare. Again, this is a pair bond between one female and multiple males. And there are two ways in which this can happen. It tends to be concentrated in some chariadra forms. So spotted sandpiper, phalaropes, a couple of species of jacanas, and some rails are polyandrous. One interesting fact of this is we tend to see reverse sexual selection where the females are showing the sexually selected traits associated with dominance like larger size and aggression, and also brighter coloration. So there's female-female competition and male choice as the forms of sexual selection. So female jacanas are very aggressive. They destroy the eggs and nestlings of competitors in their neighboring territories and try to recruit those males back to their territories. So as I mentioned, there are two ways in which this can happen. What I was basically just describing there is what's called classical polyandry. In these situations, females are defending territories and they're trying to recruit multiple males. A male that chooses a female mates with that female. He then makes a nest, and then she, over a period of several days, will mate with that male and lay eggs into his nest, in which he is responsible for all of the care. So in a situation like this, clearly the males are going to be very choosy to make sure they're mating with the highest quality female possible, because it does limit their quantity in this situation. But there are some advantages, even in this situation, to being the first male to join a female on a territory. He's likely to have all the paternity associated with his brood, but subsequent males that come in, he may continue to sneak copulations with that female, or she may be stirring sperm from previous matings with him, so that he does share some of the paternity in subsequent males that join. And this figure is demonstrating that here. So in situations where, I wish this would just stay on, you just have one male. When we say a polyandrous species, usually that's associated with some territories that really are just monogamous, but others in the population, polyandry is common. So the females that are mated in a situation with just one male, there really isn't much extra pair paternity in those situations, but with multiple males there is, and the more males there are in the territory, you can see the highest level of extra pair paternity that you see. So that's classical polyandry. Cooperative polyandry is even a rarer form in which males will assist at the nest of female. So it's a single nest in which multiple males will mate with the female and work together to raise those young. And so the female's task in a situation like this is to convince each of the males that she mates with that they have at least a shot of having some of the paternity in that nest. And that's how she should basically use them as helpers at those nests. So this is seen in Galapagos hawks, which are pictured here. Harris hawks that we've talked about, the ones that I described doing the group hunting of the rabbits earlier in the semester in West Texas and Arizona and New Mexico. They also show some cooperative polyandry. And the hedge sparrows, the dunnocks that we talked about, where the males will come back and if they suspect their female has mated with some of these rival males, pecker cloaca. So there's not, the males are not necessarily getting along always in the situation. There is still some competition, but if they feel again like they've got some paternity associated with the nest, then they can all help at the nest. Okay, lastly, I just wanted to talk about promiscuity. Promiscuity is dealt with differently and defined differently by different behavioral ecologists. I like the way of describing promiscuity is mating with no pair bond, simply that, where individuals come together and mate and go their separate ways. Don't be fooled, however. The general kind of use of that term, at least in human societies, a promiscuous person is one that's not choosy. In some cases, promiscuity is associated with being exceptionally choosy because you're really going after the highest quality individual possible. This is particularly from the female's point of view. So keep that in mind. So in some of these promiscuous mating systems, we have some of the most extreme examples of male displays. So one way in which promiscuity can come about is kind of like the resource defense polygyny, in which males are defending a clumped resource that attracts several females. But in this case, instead of like the red-winged blackbirds where the females would settle into the territory and nest, females just use the resource, mate with the male, and then leave. And they're off on their own to nest by themselves and take care of the young solitarily. This is pretty common in tropical species of hummingbirds that are defending these large flowering trees, for example. Also frugivores, they're defending dominant males defending fruiting trees that are these kind of limited resources that can attract females. But again, the females just come in, they mate, and then they take off. But the females are getting a resource out of this. One really prominent form of promiscuity is called lekking. And lekking is associated with males gathering in these pretty commonly described traditional mating areas where they display together in their little display territories. These territories could be kind of spread out. The more traditional leks that we talk about are something like a prairie chicken, where males will defend territories that are about maybe 2 to 3 feet in radius, and there could be, say, 20 males in an area of an acre. And in these situations, what the females are doing is they're just kind of coming in, looking at the lek to pick which males to mate with. One important definition associated with a lek is it is truly just a breeding ground. The females are visiting only to mate. They don't get any other resources at the lek. And that's an important kind of definition of what a lek is. So birds of paradise, pictured on top here, these are lekking species. And the mannequins down lower, the males in this lek, we'll talk about, they're actually doing what's called a cooperative lek, I'll explain later. But that's all they do, is they display and attempt to mate with the female, and then the female on the left here mates and then goes off to build the nest and raise the young on her own. So as I mentioned, the density of males at a lek can vary. So it can be a relatively dense, small display area, as I described for something like a prairie chicken or these black grouse seen in the top right in this figure, or an exploded lek, where you still have males that are relatively concentrated in an area, but they may not necessarily be in visual contact with each other, but they will you can actually hear them displaying in territories nearby and in denser forested-like habitats, like this great Argus pheasant shown here on the right, or this manakin shown here on the bottom left. In lekking species, you tend to show extremely high reproductive skew. What that means is that there are just a very few males that get the vast majority of matings in the population. So there are big time winners, and then it rapidly dwindles down to losers and even more extreme losers. So in most cases, maybe 10 to 20% of the males get 70 to 80% of the matings. So as shown here with this sage grouse, you can see that the alpha male, the one listed as number 1 here, got almost 50% of the matings in this population, and it really dropped off distantly to where most individuals below rank 5 maybe got 1 mating, and that's usually associated with sneaking a copulation and not actually having the female choose you. So, but choice is really what's going on here. So there is extreme sexual selection pressure to be this alpha male. I mean, if you're that alpha male, your fitness is so much better than everyone else's that your genes are going to drive the evolution of these sexually selected traits in your species. So, if most of the males aren't getting anything out of this, why do low-ranking males even participate? Why do they show up to these leks and even try to display? Well, there are a couple of reasons for that. One I've already hinted at, but first I want to talk about the idea of alternative reproductive strategies. The 2 birds shown here are what's called leks. Rough. They're a Scandinavian species of sandpiper, and there are multiple forms of males that are genetically determined. So this darker male is a territorial alpha male, and the whiter one here is a subordinate satellite male. It turns out that the darker territorial males get most of the matings in the population. The satellite males, the lighter ones, only get in a year about 15% of the matings. And this is genetically determined. So how do those genes stay in the population? It doesn't seem like that would work, because eventually the darker males, again, should be driving this genetic system. Well, it turns out that there's a balancing element to this story. These are both what we call evolutionarily stable strategies, meaning that the lifetime fitness of both of these male types is equivalent. So they actually do have lifetime reproductive success that's the same. That's driven by the fact that the dark territorial males may mate a lot while they live, but they don't live very long because it's a stressful life, and the satellite males don't mate a lot per year, but they live long enough so that they turn out to have just the same reproductive success. So it's a fascinating story. But in most cases, the subordinates really are not doing well. The sneaker males, they may be gathering around a dominant male to do what we call making the best out of a bad situation. Sure, they may just go try to display by themselves in isolation, but females wouldn't give them the time of day. They wouldn't even visit near their display area. But if they're around a dominant male, that dominant male's mating with another male, or the dominant male is fighting a challenger, then you may be able to sneak copulations with the females that are in the area. So you're not going to have as good a success as the dominant male, but it's better than nothing, and it's better than you could have done on your own. And if you're a young male, this is another important point, just bide your time. That dominant male is going to die off, and maybe you will become the dominant male in future years. So I mentioned previously that this one species of manakin, it shows what's called a cooperative lek. They show group displays in which there are males of different dominance and subordinate status. And the subordinates, as you would expect, don't get many copulations, or in some cases absolutely zero copulations. And so the question there, especially in the latter case, well, why do they participate at all? And it turns out that these associations of males are long-term, and they're associated with that lekking site, and they do these coordinated displays as shown here kind of on the right, where they do these really fast acrobatic displays in a coordinated fashion, and the female is impressed with how synchronized this display is. And the site itself, that lekking site, gains a reputation as a quality site. And the alpha male eventually is going to die. And the beta and gamma individuals that are kind of down the list, if they're younger, that's what they're doing. They're just helping to build the site's reputation so that females that come in the previous year may come in future years. And if the alpha male has died off, the interns, so to speak, have moved into that position and may gain some fitness at that point. So they're getting fitness. It's a delayed event. Sometimes, however, in the case of the mannequins, it turns out that those are unrelated individuals. In other species, though, like in wild turkeys sometimes will display in these coalitions. And microsatellite analysis has indicated that the coalition members are related, and oftentimes they are full siblings. They're brothers. And that's what this figure here is showing you. If you look at the relatedness of brothers and other full siblings, mothers and offspring should be about 50%, and sure enough, that's what the coalition males are. So that's the indication that these are probably brothers. So why? What does that matter? So it turns out that if you look at the matings, the dominant males, oh, come on. The dominant males getting a lot of matings, right? So in about 13 up here. Look at the subordinate males. They get jack. They don't get anything, right? So why don't they just go off and be solo males? Solo males are getting some success. Okay, what's going on here? Now, if you look at it, so that's just cumulative matings. If you look at actual reproduction, though, now we start to see something. The dominant male, again, the subordinates aren't getting anything, but the dominant males are getting, probably that looks around 50, around 50 total offspring. Solo males, what is that, probably around 18, 17? That's definitely less than half of that. So here's the deal. So it still looks like the solo males are doing better than the subordinate males, right? But here's the deal. If the subordinate males are the true brothers, the full siblings of their dominant males, then they can benefit through what's called kin selection. Kin selection is an alternative route to fitness, and where you may not be directly passing on your genes to your offspring, but if you can substantially increase the reproductive success of close relatives, then that extra that they produce, that's just like your genes. And so if you can't reproduce, or you could reproduce as much as a solo male, but you can do so much better by helping your brother breed, well, your brother's definitely getting that advantage above and beyond what, say, the solo male could do here. But all this also counts to your fitness, because he wouldn't have been able to do that if it wasn't for you. So you are indirectly getting fitness, and that's what it's called, indirect fitness, as opposed to the direct fitness you're foregoing as being a solo male. So this type of cooperation, due to this benefit of indirect fitness, is driven by an evolutionary force called kin selection. All right, so we've got the individuals together and they're breeding under different mating systems, but they can also occupy the habitat in different areas, be territorial or colonial to some degree. And it can vary between very closely related species, like bank swallows shown here on the left and northern rough-winged swallows shown on the right. So you're probably most familiar with the birds that are territorial. This is where a pair of birds typically defend an area for the use of themselves, the breeding pair itself, and the young that they raise. And they set up these perimeters and drive potential rivals away. And we talked about the importance of song in establishing these boundaries throughout a breeding season. And here you can see a situation in which we have territories of varying quality. That this would be definitely a situation where you might expect to see something like a polygyny evolve, where you'd see these really high quality territories attracting more females than these kind of loser territories out here on the edge. So when we do have situations like this, whether it turns to polygyny or just strictly monogamy anyway, you usually do have varying habitat quality. And there's a clear pattern typically associated with how territories fill up when there is that type of variation. It's best understood if we think about a migratory species. So a species is migrating north from a southern wintering ground. As they get into the settlement range where they're going to breed, clearly the first arriving individuals are going to try to set up territories in the best habitat. And so the x-axis right here would, you can write down here like number of territories. So this is the number of territories of each type. And so let's say that this is 5, 10, 15. So the first 5 that are settled here, those are high quality territories. Boom. But after that, there aren't any more. There aren't any more high quality territories. Okay, so that levels off. You're not going to get any more of those. Oh, so I guess the number. Sorry, the number's over here. This is time. Yeah, sorry. The x-axis here is the arrival order of males. So the first 5 males, let's say, are establishing these first 5 territories in the primary habitat. Okay, what about number 6 male when he comes in? Well, there's no room in the inn at the high quality territory, so he's going to take the next kind of class of habitats that are available. So they'll start going into these secondary habitats until those are full, and then eventually you get to the point where maybe 10 males have arrived. And that's 10 territories is all you got. You got 5 high quality. Well, let's say that this was only 3, I guess. So only got like 3 of the lower quality territories. All subsequent males then become what we call floaters. So here are the number of breeders in the primary habitat. Here are the number of breeders in the secondary habitat. This is the number of individuals that are floaters. And floaters basically are trying to just exist in marginal habitats and sneak into breeding territories to utilize resources and maybe to sneak copulations with the breeders. And the way I described it is more of a solitary existence for floaters, and that is typically what you see in most North American species. But in some cases, the floaters can actually exist in flocks, where these floater flocks can act as gangs in some cases and raid territories for resources, or to come into the territories and distract the male while some of them sneak copulations with the females. So that can vary. In some tropical species, we'll find out that tropical species tend to live a lot longer than comparable size and closely related temperate zone species. The fact that the territories are not increasing in number, there tends to be a backlog of potential breeders that are existing as floaters. And so they can make up a substantial part of the population. And that was demonstrated in a study in Costa Rica on rufous collared sparrows. They made up about 50% of the adult population. All right, so let's talk a little bit about some of the patterns associated with territoriality. Especially when we talk about migration, which is going to be the next topic, there are some really big time advantages to be the first migrant to arrive. Again, you're probably going to get the first crack at the highest quality territories, and you also have the greater ability to defend those territories from what's called resident advantage. There's a general pattern seen in animals, birds included, in which once you've established a territory, you tend to fight harder for it, and it's harder for individuals to take it away from you. So it's kind of like possession is 9/10 of the law. So we call that resident advantage. And initially in the breeding season, we talk about how there can be a lot of aggression between neighboring males and determining where those boundaries are. But then once the rules are kind of set, the neighbors will actually help to defend each other's territorial boundaries against any kind of intruders that come in that, again, don't know the rules and could disrupt the kind of status quo that has existed once the territory boundaries were set up. And the idea that that's what's going on is called the dear enemy hypothesis. We talked about that when we talked about the function of song and territoriality. So territories in some species can include more than just a breeding pair and their young. It can be associated with multiple generations of individuals living in these larger social units. And this is generally referred to as cooperative breeding. That's what's seen in acorn woodpeckers here. They live in these larger groups in which the parents will live at the same time as their older young from a previous nest that are helping them raise their younger brothers and sisters at another nesting attempt the subsequent year. Cool thing about the acorn woodpeckers, what's shown here is what's called a granary tree. The granary trees are where they've pecked these individual little holes to cache acorns. And these cache trees, which are called granary trees, can have thousands of individual holes where they've placed these acorns. And so the number of these granary trees and the number of stores that they have in them is a big determinant of territory quality, and a big determinant of how big those family groups will be, and individuals will stay helping mom and dad, hoping to inherit that territory and utilize the resources in the meantime. So, not all species are territorial, and there may be even times when they are not territorial, or the size of the territories that they defend will change depending upon a variety of reasons. One reason why you may not want to defend a territory is if the resources you're defending are just not predictable in time and space. Quickly changing resources are just not worth spending the time and energy to defend a set area if that resource is going to move and be gone the next day. So think about schools of fish. It doesn't make sense to defend areas in the ocean or a water body. If you're specialized on feeding of swarms of insects like locusts, again, that's not going to make any sense. So instead, what you see is you don't see territoriality, you see scramble or exploitation competition that we talked about previously. Even species that are territorial can adjust their territorial behavior, and that's a classic study of that was done on the golden-winged sunbirds in Africa, where flowers can vary in their quality and their regeneration time. And so if you find a really good patch of flowers, you might want to spend the energy to defend those flowers. But if the flower patches are relatively poor and you can just basically ink out a living by defending those, just go to scramble competition and use it, and not really try to worry about fighting off any potential rivals. They demonstrated this with an experimental study in which they used artificial flowers that they made either contain 1 milliliter of nectar or 2 milliliters of nectar. And they found that when they made them really valuable, the defended flowers, you see, so go off over here to the right. I'll try to do this without changing. So we're looking right here. Oh, this is not that easy. So if you look at their foraging, they'd spend about 4 hours in an 8-hour period foraging. and that's pretty energetically expensive, about 4 kilojoules per hour. So that's a lot of energy to do that. But look at how much energy it takes to defend that resource. That's really energetic, chasing off individuals with really high burst flights and attacking them. But you don't have to do that for very much. So it's very expensive, but it doesn't take a lot of time. So it really doesn't add up to that much cost. So they spend actually a lot of their time just sitting, just literally sitting there waiting for these territorial intruders, and then foraging about half the time. So their total daily energetic expenditure is 26 kilojoules. Now let's contrast that to the undefended. Well, since they're undefended, they don't have any costs associated with defense, but they also don't have any time to sit down. They're just constantly utilizing those resources. So for the full 8 hours, they're spending that 4 kilojoules per hour, which adds up to be 32 kilojoules per hour. So it's actually costs more to just do scramble competition in here than defend the flowers. But you just don't have the extra to spare to do the defense because the defense is so costly. And the resource just really isn't that valuable. So definitely you would want to find the higher resource value and defend it and be territorial, but as a backup, just be non-territorial and just go into scramble competition. Well, what about superabundant resources? Superabundant resources, surprisingly, you treat them like they're not very valuable resources. You just want to use them as quickly as you can. It's really not worth defending those because they would be so valuable that they would attract so many competitors that you just spend all of your time in these very energetically expensive protection mode. And anyway, there's more resources there than you could consume on your own anyway. So there's really less of a need for you to worry about it running out. And so if you look at most foraging shorebirds on a shore, they'll maintain their own individual spacing. You don't want to get too close to a foraging individual, but they'll forage in these flocks and just try to eat it as much as they can and not really show much territoriality. And really that makes sense for other reasons. Remember, we talked about how foraging in groups has other benefits associated with being safe against predators. Predator detection, seeing them farther away, seeing them sooner, and then if someone in your group is killed, you could benefit from the dilution effect. Okay, what about territory size? Here's a graph that shows that as you would expect, the bigger the bird, the more resources it needs, and so the larger the territories that they have to defend. But this does depend on what they eat. So birds that are more herbivorous, the slope of this curve does not go up as quickly. And that makes sense totally because of just think about the energy pyramid. There are just more plants available in a per unit size than consumers, and the farther you went up in the consumer role, so probably a lot more insects than would be available than birds that are eating those insects if you are, say, an accipiter hawk eating those birds. So the predator line here that's broken up and just to differentiate it from herbivores, if you're mainly eating insects, that wouldn't be as steep as it would be for if you were a top predator, so like a raptor that is going after the individuals that are actually eating the insects. So let's say that you are territorial. What size territory should you defend? This is a question of what's called optimal territoriality. And there are costs and benefits associated with defending territories of different sizes. And so I really want you to know this figure here to the right. As you defend a larger and larger territory, the cost will continue to increase. It's just more flight time, more potential competitors will be trying to utilize that resource. So those costs are going to increase. And here it's showing a linear increase. But really, you could imagine situations in which it may be kind of like a curve like that. So that once you get to the really big territories, boy, it just really is very cost prohibitive. But regardless, you also have benefits. So the bigger the territory, the more resources you're getting, but then eventually get to the point where you've got enough anyway, and you may not be really getting any more benefits from defending a larger and larger territory. At that point, the cost and the benefits are going to start getting closer and closer together. Also, the cost and the benefits are going to be pretty close down here, right? So it doesn't really cost much to defend those territories, but you're not really getting much of a benefit out of defending a small territory. So where is the optimum? Well, clearly the optimum is wherever the benefits are the highest relative to the cost. So wherever the biggest gap is between this line, that will indicate where the optimal territory size is here on the x-axis. See, you're really glad I wasn't in the same room with you right then. You're just screaming coronavirus. And where I kind of draw this curve, it looks like it's actually kind of the same place. But this would change exactly whatever is the benefit and cost curve here. And for a species, these curves are going to change year to year. Certain years are going to be more resource rich versus resource poor. And that's going to change the benefit and cost ratio. Population density is also going to impact the number of competitors you'd have to chase. So that could also change the dynamics associated with the cost-benefit ratio. Generally, the more dense the population, the smaller the territories are, because the cost of territory defense just becomes much greater and really shrinks that down, so that it would drive the optimal territory down here. So not all species are territorial. Colonial nesting is seen in quite a few species. It's oftentimes seen in oceanic foraging species, again because you can't really defend a resource associated with foraging in that situation. And there are actually benefits of colonial nesting in finding those food sources. So we've already talked previously about the information center hypothesis of how individuals can go out different directions looking for resources, and then those that find the food come back, clear indication they found the food, and individuals that didn't find food that day will follow those individuals back out to find that school of fish. They can also work together in defending the colony against predators, so there's mobbing of nest predators in that situation. And if you're a dominant individual, you may gain from some extra pair copulations. And if you're a female, you may be able to produce enough eggs not only to raise your own young, but to sneak a few eggs into the nest of conspecifics, and this is what we call intraspecific brood parasitism. So you could gain fitness in that regard. But clearly there's some costs associated with colonial nesting. There's the potential to attract predators. So that yes, there are some benefits, anti-predator benefits of being in a group, but you actually may attract more predators. Well, that's one of the reasons why you see colonial nesting birds nesting in areas that are less accessible to predators. So like these cliff swallows here on this cliff, or in the previous picture, those oceanic birds nesting on that isolated island and that kind of slope. And when there's one individual benefiting from extra pair copulation or brood parasitism, other individuals are losing, right? So if you're the dominant individuals, you may be benefiting from that, but if you're a subordinate individual, you may be losing paternity associated with extra pair copulation, or you may be taking care of someone else's young if they snuck an egg into your nest. Another real potential cost associated with coloniality is the spread of diseases. I mean, that's exactly what we're demonstrating now with this social distancing. By packing all these individuals together, they're more likely to spread diseases, and that could be viral, it could be bacterial, or it could also be insects, in this case, arthropods, arachnids. In this figure B here, this was a study by a professor at the University of Oklahoma, Tulsa, I believe. His name literally is Charlie Brown, great biologist, and he studied, I think it's cliff swallows that he's been studying. And one of the things he noticed is that nests that have really high parasite loads, the young just don't do well. And so he did this cool experiment where he fumigated some of the nests randomly and looked at the difference it made to the young. These individuals in B here are exactly the same age. This one is associated with a non-fumigated nest. This is one fumigated with a fumigated nest. This one had ticks all over it, and clearly that affected its development. This is such a problem in this species that Brown found that after just a few years of using the same location as a nesting site, they have to completely abandon the nest because the ticks can kind of build up in the old nest sites and invade nests the following year. And so they just have to abandon them for a time period. So in these social species, one of the things you do see is individuals still maintaining some personal spacing to reduce aggression between individuals. So like these swallows on a line, sandpipers at a beach, they will huddle when they get cold. And dominant hierarchies are really important in establishing stability in these social groups. So dominant individuals certainly do get the best of resources, the best nesting locations typically in a colony, and they get better mating, mates quality, and more extra pair copulations. But the subordinates typically put up with this because they still do better living in the group than they would on their own. And as we talked previously, the typical relationships of dominance are associated with size. Males tend to dominate females, and older tend to be more dominant than younger individuals in these social groups. And they communicate these levels of dominance by vocalizations. Submissive vocalizations tend to sound like begging young. Physical displays or appeasement displays are try to make yourself small, turn your head away, your bill away. Dominance do the exact opposite, puff yourself up, point your bill up high, or kind of show how it could be used as a weapon. For species that have crests like Steller's jays and blue jays, and titmice, they can control how elevated that is, and the more erect it is, the more angry they are. The more flattened it is, the more submissive, and again trying to look small and appease any potential competitor. More long-term dominance displays can be associated with plumage, like the darker bibs and house sparrows and house finches. And Harris sparrows. The house sparrow, we saw that in the video earlier where it showed them fighting over bits of food, and one of the biggest bib was the most dominant. They've actually demonstrated this with dying individuals that are comparable or even less dominant in reality, and they do get a temporary advantage by giving these signals of dominance. But eventually someone will challenge them, so that there is at least occasional testing of these dominant roles, so that these signals can be maintained as honest signals. And lastly, one of the things that likely occurs more in social species is individual recognition. It's important to know who is dominant, and who individuals are that you've already challenged for dominance by recognizing them as individuals. And so there's more variation in vocalizations in social species, particularly in the young of swallows. Ruddy turnstone is shown here. This is one species of bird that shows such amazing diversity that if you were studying these, you wouldn't even actually have to band them. You could take pictures of them and just see these different facial markings to identify individuals. And you could use that to identify them and give them basically names. Now, most birds don't have that degree of pattern variation that we can see, but again, they can see UV, and so there may be more variation than we know. And obviously they probably are just better at finding the subtle differences between individuals within their species than we would be. Okay, that is the lecture for now. I will send another one out soon.